Okay, so day one is special right triangles. Two different types of triangles we're going to look at. We're going to look at this kind of triangle over here and these triangles over here. This is from the SAT formula sheet. So do you guys remember when you've looked at those practice SATs before that you get a formula sheet? You're given these two. What is this formula? Pythagorean theorem. Can I use Pythagorean theorem for every single triangle no matter what? No, has to be a right triangle. So just remember, has to be a right triangle to use Pythagorean theorem. Last year, do you guys remember 30, 60, 90 and 45, 45, 90 triangles? Yeah. Does that at least ring a bell a little bit? Okay. Here's what I do for 30, 60, 90 and 45, 45, 90. For this triangle right here, I always write the angles. And then I write the ratio of the sides. So across from the 30 is an x. Across from the 60 is an x root 3. And across from the 90 is a 2x. Is that similar to what your teachers last year did? Yeah. Okay, some yes, some no. This one, same idea. So 45, 45, 90. So your two 45s are the same. Across from the first 45 is an S. Across from the other 45 is an S. Across from the 90 is an S root 2. Now, I don't know why the formula sheet used X and then S. It doesn't matter. So you can pick whatever variable you want. So we're going to do a few examples. If we were to look at question 1, which applies? Pythagorean theorem, 30, 60, 90, or 45, 45, 90? Pythagorean theorem. There's no marking on the angles at all, so you're going to have to use Pythagorean theorem. So we have a squared plus b squared equals c squared. In this formula, what is most important? Which side is the most important? C. And what is C?
Hypotenuse.
Hypotenuse, across from the 90. So you're going to have root 19 squared. And then it doesn't matter which of the other two sides are a and b. So equals x squared add root 7 squared. What is root 19 squared? 19. So we get 19 equals x squared add 7. Subtract the 7. So we get x squared equals 12. What do I do from here? Square root. Make sure you simplify the square root of 12. So I get 4 and 3, 2 and 2. What do you have to remember anytime you take a square root?
Plus or minus.
Yes. So we get x equals plus or minus. 2 go outside the root or underneath the root? Outside the root. So we have 2 root 3. Now, do both answers make sense?
The minus one doesn't use
Side. Side. Negative sides don't make sense. So I want to see this answer, but then I want you to know that only the positive answer works. Right? Negative length wouldn't make sense for a side. Okay. Are we okay on Pythagorean theorem? Okay. We're going to do problem 3 then. We'll go back to 2. Problem 3 is a 45, 45, 90 triangle. So you're going to start by writing the ratios just like I wrote at the top. 45, 45, 90. The side across from 45 is an S, S, S root 2. Okay, so now what you're looking at, the side that we have is across from 45. So underneath 45, you're going to put a 6 because that's the side we have. Now, this tells us that S equals 6. So then this S will also be a 6. S root 2 will be 6 root 2. So, side we are looking for, the X, across from the 90. That would be this column. So we would say that X equals 6 root 2. Okay, I want to do one more like that because I think that these are a little bit confusing. And then you guys are going to do some. Problem 4, 30, 60, 90. The ratio we wrote at the top is x, x root 3, 2x. Now, first question for you, something I want to make sure we understand. Do we know that this x is not the same as that x?
Yes.
This x not the same as that x?
Yes.
These x's all come from up here? Okay, so for right now, ignore x and y. 8 is across from the 90, so what am I going to put under the 90?
16. 8.
8. 16 is what we think it should be, but it's what the side actually is. So the side across from the 90 is actually 8, so that's where the 8 goes. So here's what that tells us, that 2x equals 8. So now we know that x equals 4. Again, not the x on the triangle, the x in our ratios. Okay, so then this will be a 4. This will be a 4 root 3. So going back to our figure, x is across from the 30. Across from the 30 is a 4. So x equals 4. Y is across from the 60. So across from the 60 is 4 root 3. Does this stuff seem familiar? Yes? Okay, here's what I want you guys to do. Right now, you are doing question 2. And then on the next page, you are doing 5 and 6. So I'm going to give you 4 minutes with your new partner. So move your desk with your new partner and start working on those problems, please. Hey, move together. On the next page.
Oh, yes. Are we just doing 2?
So you got like a minute and a half left to see how far you can get.
Yeah.
Okay, I know you're probably not finished, but some people are, and I just want to keep us kind of moving. Problem 2, you should have gotten 5. Should have used Pythagorean theorem. Again, it's important to me to show that x equals plus or minus 5, but that 5 is the only answer that makes contextual sense. That one go okay? Yeah? Okay, 5 and 6, I left you guys the 2 hardest ratio questions, so let's see how we did. 45, 45, 90. Should have started with the 2 ratios. So this is s root 2. We know the side across from the 45. What do I put under 45? 9 root 2 or 9?
9 root 2.
9 root 2. The side is actually 9 root 2. So the side across from 45 is 9 root 2. So this tells us that s equals 9 root 2. So then s is still 9 root 2. Here, I'm going to write s, which is 9 root 2. And then there's another root 2. So this is s. That's the extra root 2. Now, what is 9 root 2 times root 2? 9 root 4. Square root of 4 is 2. So we get 18. Okay, so the x that we are looking for is across from the 90. So that means that our x is 18. How many people got that? Okay, good. Problem 6. You could use Pythagorean theorem. That's not what I envisioned you using, so that's not what I'm going to use. What is my other option besides Pythagorean theorem? And why am I allowed to use 45, 45, 90? Hey, guys, somehow I feel like only 3 or 4 of you are actually listening to what I'm saying. What do you call a triangle where 2 sides are the same? Isosceles? Isosceles. Do you guys remember if the 2 sides are the same, the 2 angles have to be the same?
Yes.
Okay, so I envisioned you, or I wanted you to treat this as a 45, 45, 90. So we get s root 2. We know the side across from the 90. What am I going to put under 90? 8 or 8 root 2? 8. So the side across from the 90 is 8, so you keep an 8. Okay, this is the hardest type of problem. We end up with s root 2 equals 8. How do I solve for s? Okay, I could square it. This is where we have to be careful. What is the left side going to end up being? S squared times 2, right, equals 64. So we divide by 2, square root it. So this ends up being 16 and 2, 4 and 4. So we end up with s equals plus or minus 4 root 2. Again, the negative, though, doesn't make sense. So our s is 4 root 2. Hence telling us that x equals 4 root 2. So here when you are squaring, make sure you square both the s and the root 2. Okay, questions on 45, 45, 90, 30, 60, 90, or Pythagorean theorem?